Hello. So we are learning the elasticity of demand in class. Here is a question from homework. Consider price demand equation given by this. Which of the following gives you the value of P for which the elasticity of demand is elastic? Now, before even we think about the question, when we're talking about elasticity, we need to know about elasticity of demand function. The value is negative P times d dash of P divided by d of P. Now, in this question, d function as in function of P is not given. What is d function? You need to remember d means demand and price is given as a function of demand. So basically, we need to find x from this equation. If we do that, that x will be your demand function in terms of P. So this equation is given. This is giving you P in terms of x. We need to solve it a little bit. Let's write it down here. P is equal to 6000 minus x divided by 1200. The first step would be to solve this equation to find x in terms of P. So I'm going to do cross multiply. This will be 1200p is equal to 6000 minus x. So add x on both sides and subtract 1200p. That would be 6000 minus 1200p. That would be your demand function. So let's write it one more time. Demand function now is 6000 minus 1200p. Okay. Now we have the demand function. That was your first problem in the question, that you didn't even have demand function, right? We couldn't even talk about the problem. So now let's talk about the elasticity. We need to work on elasticity. So elasticity is negative P times d dash P. So before doing that, let's find the derivative of this function also, which is with respect to P. Derivative of 6000 will be 0. Derivative of negative 1200p would be just negative 1200 using the power rule. So derivative is negative 1200. So using all that, I can find now my elasticity function E of P. That would be negative P times d dash P divided by dP. We have everything. Negative P is written as is. D dash P is 1200 divided by dP is 6000 minus 1200. So write that. So what do we have? 1200p divided by 6000 minus 1200. This elasticity function, but we can simplify a little bit, I think. Let's write, let's see if we can factor out 1200 from the denominator. 1200 times 5 is 6000. So this is what we have, and 1200 will be cancelled. So 1200 is cancelled. Our elasticity function is P divided by 5 minus P. Now let's read the question again. The question said, for which value of the P, the elasticity of the demand is elastic. So we learned in class, when is elasticity elastic? If E of P is more than 1. So we need to find when elasticity is more than 1. That means P divided by 5 minus P is more than 1. That is our question now. Okay, to find the P values for which this expression is more than 1. Now, this brings to our first section of the course where we solved inequalities on the right hand side, but it's 1. In those inequalities, right hand side was 0. So I'm gonna bring 1 on the left side by subtracting, so I can make the right hand side 0. So this is my, I'm going to leave the question behind for a minute and I'm going to try to solve this inequality. Okay, so I have to solve this rational subtraction first. P minus, I have to multiply here, positive, that is p minus 5 plus p divided by 5 minus p more than 0. That will look like 2p minus 5 divided by 5 minus p positive. Now this looks like that. You remember we have to find partition numbers here. So partition numbers are where this function becomes 0. So the function will become 0 at 5 by 2 when the numerator becomes 0. And where this function becomes undefined, that is where the denominator will become 0. So that is 5. So two partition numbers. I'm going to draw a chart, sign chart. So I have 5 by 2 here and I have 5 here. I'm going to pick a random number between these three regions and check the sign of the function and see where it is positive. So you know all that from our first section. So I'm going to do it faster here. So I'm going to pick a random number here. Let's say 0. Some number between 5 by 2 to 5. Let's say that's 3. And some number after 5. Let's say that is 6. So let's plug in 0 in the given function. The function is 2p minus 5 divided by 5 minus p. I only am concerned that is the function positive or negative when we have p to be 0. So if you plug in p 0, this is going to be negative. If you plug in p to be 3, 2 times 3 is 6 minus 5 positive, but the denominator is 5 minus 3, so that will be positive. And the last one, 6. 2 times 6 is 12 minus 5 positive, but 5 minus p, 5 minus 6 is negative, so that is negative. So I got that here the function is negative in this region. In this region, the function is positive, and here the function is negative, right? So how will we write the answer? We wanted to know where is this positive? Where is this positive? Between 5 by 2 to 5. 5 was undefined and 5 by 2 was 0. So we are, and it's just strictly positive. There is no equality here, right? So we need to answer 5 by 2 to 5. That means P should be between 5 by 2 to 5 for the elasticity to be elastic. So if you notice 5 by 2 is 2.5, the answer should be P is between 2.5 to 5. That should be your answer. Okay. So just to summarize, in this question, P was given, but you needed demand function. Demand function, you really need to remember that demand function is basically X. Okay, so you need to find X in terms of P, that will be your demand function. When you have that, write X as your demand function and then find the elasticity and check for it to be elastic. When is it elastic? Meaning solve the inequality. So this question is bringing the whole thing together, the first chapter, the second chapter, and the third chapter. Okay, let me know if you have any questions.